To conclude section 2.6 on applying trigonometric ratios, we'll look at a few more application questions. So in this example, irrigation crops, a farmer uses a boom sprayer pulled by a tractor. The nozzles are 50 centimeters apart and spray at an angle of 70 degrees. To the nearest centimeter, how high should the sprayer be placed above the crops to ensure that all the crops are watered? So we have a triangle here, okay, and if this distance here is 50 centimeters, that means from the middle of this triangle to the middle of this triangle is also 50 centimeters, which means the whole base of this triangle is also 50 centimeters. And if I was to drop the height, which is right down there, it's going to cut that angle in half because this is an isosceles triangle, which means that this will be 35 degrees. And half of this length on the bottom is going to be 25 centimeters. So if I was to redraw that diagram, okay, I would have the 35-degree angle up here, and this distance would be 25 centimeters, and we're looking for the height of the sprayer. Okay, so based on that angle of 35, I know the side opposite. I'm looking for the adjacent, so I am going to use the tan of 35 degrees is going to be equal to 25 over h, and if I was to isolate h, it's going to end up being 25 over the tan of 35 degrees. And then you're going to get out your calculator and you would evaluate this quantity. So using my calculator, I have 25 divided by the tan of 35 degrees. And if you round off to the nearest centimeter, that's going to be approximately 36 centimeters. So you would say that the height of the sprayer should be 36 centimeters, and that would be the end of the first problem. All right, in the second example, I'm going to ask you to pause the video and see if you can set this one up and give it a try. Okay, I'm hoping you had time to look at this problem. And again, we'll need a diagram, so I'm just going to insert a new page here. And it says that Anwar is designing a wheelchair accessibility ramp for his sister. He says the ramp will raise 1 foot level from the ground to the door, and the horizontal distance from the start of the ramp at the sidewalk to the door is 20 feet. So we have our base of our ramp. This is going up 1 foot, and here is the ramp right here. And it tells us that the horizontal distance of the ramp is 20 feet. And it tells us that the incline must be less than 5 degrees for it to be acceptable. So we're looking for the angle of incline. We'll call that theta. So again, I know the opposite side of theta and I know the adjacent. So again, I'm going to use the tangent of theta is going to be 1 divided by 20. And now I want to find the angle, so I'm going to take the arctan of both sides. By doing that, I'm going to get theta is going to equal to tan inverse, or arctan, of 1 over 20. So again, using my calculator, arctan of 1 over 20, this works out to be 2.9 degrees. So therefore, yes, this ramp will be acceptable, okay? Because it falls less than the 5-degree angle of incline. Okay, there's a couple of questions for you to try. Also, you do have the handout that I gave you the other day on solving right triangles. So good luck with those questions, and if you have any problems, check out the answers on the website.